Okay, isosceles trapezoids. And again, I filled out some information just so it was a little bit easier for me when I'm trying to draw it one-handed. So isosceles trapezoids, the properties state the same thing as a regular trapezoid. So you have one set of parallel sides, which would be the top base and the bottom base. And more specifically, with an isosceles trapezoid, the legs are congruent. Okay, now the legs are these pieces, or sorry, these segments on the side. Those are your legs. As well as we know that both pairs of base angles are congruent. So this base angle is congruent to that base angle. That base angle is congruent to that base angle. Both pairs of base angles are congruent. And then as well, we know that the diagonals are congruent. Now this is specifically, they do not bisect each other. That one got a little wonky. Okay, these do not bisect each other. You can tell this is longer than that, but the entire diagonal is congruent to the other entire diagonal. Okay. So let's throw some letters on there just to help clarify that. So AC is congruent to BD. So the whole diagonal is congruent to the other whole diagonal. Now, the only other thing that we know about isosceles trapezoid stems from one of our other shapes. In this case, both pairs of the base angles are congruent. Now, because these are both congruent, we also know that consecutive angles are supplementary. Which was true in previous shapes. Okay, so let's try our problems. So for number 4, I'm going to label my shape. I'm going to draw in my diagonals. Sorry, that one always gets tricky trying to do that drawing. And what we have indicated on this is that these pieces or these segments are congruent, meaning it's an isosceles trapezoid. Okay, and what the information says is that AC equals 31. Find BD. Now, based on what we talked about up here, the diagonals are congruent. So if AC is 31, that must mean that BD is also 31. Okay, and that one's just a really short and sweet problem. Okay, nice and easy, no work. Okay, let's try number 5. Let's do some angle work. Okay, this one, fill in some information. And again, it will talk about what it is on the worksheet. So we have our angles. And then, so we have angles 1, 2, 3, and we have 105 degrees. Now, technically, we're not solving for a variable in this scenario. We're solving for the angle. So, what do we know about the information? Both pairs of base angles are congruent. So we know 2 and 3 are congruent, and 1 and 105 are congruent. So the measure of angle 1 is 105 degrees. The other information we know is that consecutive angles are supplementary, meaning the side angles are supplementary of each other. So if I know 1, I can subtract from 180 to find the other. So 180 minus 105 leaves me with 75. So the measure of angle 2 and 3 are 75 degrees. Again, another short and sweet problem with minimal work. Okay, let's try number 6. Number 6, put in our parallel lines and our congruent marks. Okay, so for this one, we got some variables. So we have 120 degrees, we have 3y as a degree, and 5x as a degree. Now again, we know that base angles are congruent, so we know that 5x equals 120. So when I divide by 5, x equals 24. Then for this angle, those would be supplementary. So we know that 3y plus 120 equals 180. So when I subtract, I get 3y equals 60 and y equals 20. Okay, great. Last problem, number 7. Throw some more algebra in there. And we have an upside down isosceles triangle. Sorry, isosceles trapezoid. And this is 95 degrees. And this is 11x plus 8 degrees. Okay, and so in this scenario, we don't have 2 base angles, but we do have 2 consecutive angles, meaning that these 2 angles added together are supplementary. So combine like terms. 95 plus 8 is 103. Subtract 103 to the other side. You get 77. Divide by 11. And x is 7. Okay, and that is what we have for isosceles trapezoids.